Hey everyone, this lesson is on multiplying polynomials. Before you multiply polynomials, we first need to review how we multiply variables. For example, if I have a y times a y, we need to remember that that actually equals y squared because there's one y here and one y here, so together that makes two y's. The same thing happens if I have y squared times a y cubed. That's going to give us an answer of y to the fifth because there's two y's here and three y's there. When I combine variables and numbers, so 2y times negative 3y, first thing you do is you're going to multiply the whole number with the whole number. So 2 times negative 3 is negative 6. Then we do the y times the y, so your answer would be negative 6y squared. One more time, if I have negative 4, y to the third, times negative 2, y to the fifth, we do negative 4 times negative 2, that makes 8. And then y cubed times y to the fifth, those go together to make y to the eighth. So now that we've done that, multiplying polynomials is actually very easy. What I recommend is using what's called an area model or a table model. I tend to call it a box. And the way it works is we look at the first term. In this case, that's a monomial. And then the second term, there's two of them there, so that's a binomial. So what I'm going to do is I'm going to make a table that's one column for the monomial and put a negative 2p up there. And then I'm going to put a p plus 3 over here. And now, when we multiply, we just multiply for each box. So negative 2p times 1p, and you can draw on the 1 if it helps you, that gives us negative 2p squared. And then negative 2p times 3 is negative 6p. Then we just bring our answers down diagonally, adding where we can, and that gives us negative 2p squared minus 6p. So I can rewrite my answer as negative 2p squared minus 6p. And you are done. So using this box is going to help you stay organized, especially as we get larger. So on this example, we are multiplying x plus 8 times x plus 7. In this case, we have a binomial times another binomial. So that means when I make my table, it has 2 columns and 2 rows. And now when I multiply, we just match. This is technically x times x, this x times that x, so x squared. This one is 8 times the x, so 8x. Then we have x times the 7, so that's 7x. And then 8 times 7, which is 56. So basically we're taking this big problem and we're breaking it into 4 easy to see problems. Then we add diagonally. X squared is by itself, so it stays x squared. We go diagonally here, that gives me 15x, and that one's by itself, so that gives me 56. So our final answer would be x squared plus 15x plus 56. Now as a review, they may ask you what kind of polynomial is this and what degree is it? If I look, there's 1, 2, 3 terms, so this is a trinomial. And then we go to wherever the biggest exponent is, that's an x squared, so that means it has a degree of 2. So it's good to be reviewing this as we go. Let's look at our next example. Our next example, we're getting a little bit bigger. Your first problems aren't going to be this hard, but the next section on just multiplying polynomials will have problems like this. So it's good to just practice it now. So if I notice this is a binomial, so I'm going to put my x minus my 4 here. And then this is a trinomial, so we're going to do x squared plus 6x plus 2. And notice I always keep the sign in front of the number it goes with, so that when we multiply, this isn't going to be a minus 4, we're going to use it as a negative 4. So now I'm just going to start filling in my boxes. X times x squared is x cubed. Negative 4 times x squared is negative 4x squared. X times 6x is 6x squared. Negative 4 times 6x is negative 24x. X times 2 is 2x. And negative 4 times 2 is negative 8. So now when we go diagonally, we actually have some diagonals that are going to need to be added. Now I have an x cubed by itself. Now when I go this way, we're going to add even though that's a negative. So 6 plus a negative 4 is actually going to give us a 2x squared. Then here, a negative 24 plus a 2 is negative 22x. And then the 8 doesn't have anyone, so it just stays negative 8. So your final answer is x cubed plus 2x squared minus 22x minus 8. And if we go to review, this has 1, 2, 3, 4 terms. So this is a polynomial. And I go to my biggest, which is right here. So it has a degree of 3. So let's try another one. Now we only have variables, but that's okay. What we're going to do is we are going to go ahead and set up our box. And I can see this is a binomial, so 2 columns, and a binomial, so 2 rows. And we're going to do negative a plus b and a 2c minus d. So now we multiply, and when these are different variables, we just can't combine them together. So negative a times 2c would be negative 2ac. And if it helps you, you can draw on that 1, so you can see that it's a negative 1. b times 2c would be 2bc. And here we have another negative, so we can draw on the 1. Negative 1a times negative 1d would give you just a positive AD. And then a b times a negative 1d would be negative BD. Now this time we can't add diagonally because these aren't the same variables. So we're just going to stick them all in a row. So negative 2AC plus 2BC plus AD minus BD. And I look and none of them can be combined. So I know that this is a polynomial with a degree of 2 because this one is a 1 and a 1. So 1 plus 1 is 2. This one is a 1 and a 1. So it's still 2, and still 2. So even when it's all variables, if you use this box, it's still pretty simple. Let's go ahead and look at one more of these. This one looks scary because if you look, it's 1, 2, 3, so it's a trinomial times another trinomial. But as long as you use your box, it's really not that bad. So I'm going to make my 3 columns since it's a trinomial, and then 3 rows. So now I have x squared plus 3x plus 1, and x squared minus 5x plus 2. So all this is just one giant multiplication problem. So starting here, x squared times x squared, 2 plus 2 means we have x to the 4th. 3x times x squared gives you 3x cubed, and 1 times x squared is x squared. And if you want, since this is a 1, we could automatically fill in this row because we know since these are all times 1, they're going to be the same. Now I can go fill in my little spots that are left. X squared times negative 5x is negative 5x cubed. 3x times negative 5x is negative 15x squared. And then x squared times 2 is 2x squared and a 6x. And now we notice all of our diagonals have the same variable. So we just have to add diagonally. So that gives us an x to the 4th. Negative 5 plus 3 is negative 2x cubed. This one we got to be careful. That's a 1 right there. So 1 plus negative 15 is negative 14. Plus 2 more is negative 12x squared. Negative 5 plus 6 is positive 1x. And then a 2 at the end. So our final answer, even though it's huge, is x to the 4th minus 2x cubed minus 12x squared plus x plus 2. So in this problem, we have a polynomial with a degree of 4. So don't worry when you see these kinds of big problems. Just make your box, figure out how many rows you need and how many columns, set it up, and just multiply. Now the next thing we have is a perfect square trinomial. A perfect square trinomial means you're going to have the same term multiplied twice. So for example, if I have x plus 4 times x plus 4, both of those are the same. You might also see it written as x plus 4 squared. When you see that, doesn't mean anything has changed. We still have to do x plus 4 and x plus 4. Even if it's written like this, we still have to write it like this. So I do x times x, which is x squared. 4 times x is 4x. 4 times x is 4x. And 4 times 4 is 16. We go diagonally. And we get x squared, 8x, and 16. So our answer is x squared plus 8x plus 16. So your key to identifying if it's a perfect square trinomial is going to be that it is the same term multiplied twice. And if we notice here, we have 16, which is 4 times 4, and 8 is 4 plus 4. So another example could be x squared plus 10x plus 25. This is a perfect square trinomial because 5 plus 5 is 10 and 5 times 5 is 25. So that means if I put it back in the original form, this is really x plus 5 times x plus 5 or x plus 5 squared. The other one you have to know is your difference of squares. In a difference of squares, it's kind of like the perfect square trinomial. We have the same terms, but notice now this is a minus 2 and this is a positive 2. What happens when we do that is if I go to multiply this really quickly, I make my box 3x minus 2, 3x plus 2, 3 times 3 is 9x squared, minus 6x, plus 6x, plus 6. When I add diagonally now, I get 9x squared. A negative 6 and a 6 cancel out, and then I get a plus 6. So my final answer is 9x squared plus 6, and this one went away. So anytime we have a difference of squares, we like that because we know automatically the middle terms are going to disappear. They turn into 0. Now we could also have a difference of squares that looks like this one. In this case, both the plus 2's are the same, but now this is a negative 3x and a positive 3x. So that's still difference of squares because all the numbers are the same. Now we just have a negative 3 and a positive 3. So another example could be a 4y plus 2 and a negative 4y plus 2. That works because these are both the same and the others, one's a positive and one's a negative. I hope this lesson helps you with the first couple of multiplying units. Let me know if you need any more help.